We talk railroads as a metaphor, and how, like the shape of the code. This is a whole new world for me. So this is something this is my first time I've ever done anything like this. The code that you're going to show, what I'm going to show you. So there is like, I'm at the present now where I am, and this talk could have like two aspects. It could be about the M words, monads. And there has been like two very good talks today on the monad stack by Clement this morning, and Jeremy just had a very nice talk about applicatives. Also, there's a book, Domain Modeling Made Functional by Scott, which is actually by Sale upstairs, which is the book that inspired me to try to work the way I'm presenting now. So my name is Aki Salmi. My Twitter handle is Rinkkasatiainen. I work at a company called Ambientia from a Finnish small-ish company, so 200 almost of us, consultant. I do work as hiking guide. I do run communication trainings. I really am really keen into NVC. I want to learn more about AWS. And yeah, if you want to talk about NVC or listening or empathy, so you can please just tweet me, and there's like the open space room also. So the example code base, it's going to be, this is not a Haskell, this is not F#, this is not all these fancy languages, because I don't know how to program with those yet. So this is a Node.js. So this is a Node.js written in TypeScript. So this is my first ever Node.js project. This is my first ever TypeScript project. That's a good place to start something like really new. I'm going to post like very small set of like what the user can do. So I'm just using one example, a use case of user sending a message. So user can send a message. There's someone who replies to it, and then the user can ask another question, like create a message thread out of that. How many of you are proficient with TypeScript or JavaScript? When I ran this previously, folks said that please do tell a bit, like a few tips on TypeScript or JavaScript. So here's like when you're going to see the code. So a couple of things here is that so the way how you can do functions is you can write. So the one here on the left, so these are the A1 and A2. It's two different ways to write a function in JavaScript. Function that returns a function, so there is B2 is a function which takes one argument, which returns a function which takes arg2, and then returns a string of arg1 and arg2. And then with multiple parameters, so you can think sort of, so if you have a function with multiple parameters, it's sort of almost the same as a function, one parameter function that returns one parameter function that does the thing. Except that with the latter, you can do carried functions, which I'm also using in the code base. When I started to work with this, this was something I thought, this is roughly the way I want this to work. I want this to be roughly a hexagonal architecture. So the domain is there, and then I have the delivery. I really love the messy ports and adapters you had in your talk. The delivery here basically mean express in Node.js, the delivery HTTP part. And then repository and database implementation down here. So a use case, so this is the use case I'm going to present here, is that a user can post a message. So what happens there is I create a command from the request, so I get a HTTP request. I parse what's in there. I need to be sure that I'm authorized to do what I want to, that I'm authorized to ask the question on that thread. Then I need to find the message entity from the database. I need to update the entity, and then I need to save the entity and then return result to the end user. Quite simple. This is very simple. Something like this. So this is like the way I've used to work. So this is sort of the domain, use case, action, the handler, and we can look at closer. So it's sort of first it checks am I authorized to actually perform this thing, and maybe it throws an exception. It checks, it validates the input message. Is this message valid? Is this like safe message to store in the database, for example? And if not, it throws an error. And then there is the domain logic that might return or returns or throws exceptions. And it's like guessing sort of folk. What's happening? And I've had struggles with Java and other frameworks. How do I handle the error cases? So do I just throw exceptions and in the roots just gather all the exceptions and figure from the exceptions what do I actually tell the user? So it's like in Node.js world, I would handle the error cases and in middlewares or in the routes. And I actually have this a bit differently also on my next slide. So the use case being the upmost is like the idea if the two upmost are like the success cases. So use case is the user wants to post a message and I want it to succeed. So I get a success response. On the middle, it says, okay, I need to authorize myself, so I'm authorized to perform the action. I need to validate the action, so the action itself is valid. And then you need to do all the domain logic in there. And hopefully I get 200 okay. Except sometimes I do get exceptions. Sometimes it throws exceptions, and this is the thing I wanted to avoid. This is the thing why I wanted to try something else, because I've done this. I've done the thing where exceptions are thrown. I've done the thing where I don't know how to handle with those. That's a problem for me with roots. So I wanted to try something else. Then I read the book, The Domain Modeling Made Functional, and then I got inspired. Well, this is something I want to try. This is something I want to try, because in the book they had this railroad tracks, and I thought, well, this is what I want to try. And then I started to work with the Node.js project, and I thought, well, why not? It's a good time as any. So one of the ideas is that the errors are the first-class citizens. So errors contains important information that whether it's authentication or authorization errors, or whether the input validation, or whether there are some domain-specific validations like domain logic errors. For example, in this case, user cannot reply or create another message if the original message is not replied to. So there is like, I can't just post a message or send a message myself 2 times without getting answer to it before. So introducing either, right? So this either is something that was both of these talks. It was like in Jeremy's talks, it was the results, and I think it was either in Clement's talk also. So either is like there's left for errors and right for success. So the idea is that I get an input, so there's a function returns an either. So either, this is left. So it either returns left, which is failure, or right, which is success. So you see the tracks, hence the name. So it's just tracks. So what it means from the data flow perspective is my data of the use case handler there are no exceptions. It just returns either a failure or a success. It just returns a failure or a success. It makes things different. I don't know if it's easier or better or something. I'll just say it's different. You'll see the difference of what it will look like. So let's take this use case, this posting this message. So there's so how it works is that I compose the whole use case out of these 6 functions. So the first 3 ones, the up there are to validate. Okay, is the user logged in? So is it authenticated? Is it authorized? And then is the message valid? And then the domain logic, finding message, posting message, saving entity, and all the domain like actions are the ones beneath. And how this sort of works is that whenever I get to the else track, whenever I get to the failure track, the subsequent functions never get executed. So if the user is not logged in, none of the functions will get executed, which is a promise. If the user is not authorized, none of the rest get executed. I sort of started to like the idea of I can work this way. So let's take a couple of these functions like closer look. So is logged in, which takes a user. So this works sort of world crossing function. So it takes a user and it returns an either monad. So it returns either failure or success of user. And the code looks like this. So is authenticated is a chainable function that, so the user or undefined means that it might, because of the way Express middleware I'm using, the request user might be undefined, so then it's undefined. So then it returns either the one on the left is to error, and the one on the right is the success, which is, in this case, it's user. So the same thing, authorizing. So to authorize thing, I need to give the stream ID there. So this is like, is authorized is a sort of 2-parameter function. First being the stream ID and the next being the user, that where the user ID and the stream ID should match, right? So it returns, again, it returns a success or a failure. So the code, what it looks like, it takes in a user, and if the user ID exists is the same as the stream ID, which is here it's called page. If those are the same, then it returns right. So I do have these statements. They are just buried somewhere, like down in some places. And if the user and the page don't match, then it's not authorized. So the thing is, I have now 2 of these functions that like user, the is logged in and is authorized stream ID functions, and I need to compose those together. And this is the part where I would say that the F# for fun and profits is a good place to start reading why this works or what Clement had. So this is like, for me, it's really hard to say why this works the way it works. So so monads and binding and those things, I'm really just trying to learn what those actually, how those work and what those are. So the idea anyway here is we need to bind these functions so that both are 2-track functions on a 2-track model like this. And then I can bind more functions together. So I can create something like this. And then whenever I get the error from this, whatever comes as the result, which is like the end result, I can then do mapping either for the error or for the either for the error or for the success, however I want. That's the bimap in the end. So what does it look like in code? So I think that's what we want to see. So this is the code that I've written myself how it works. So the first three messages. So the is valid is a function that validates that takes in a user account details and returns a type of command status. And the validate M basically it creates the first three tracks, or chains these three functions together. So it's authenticated, is authorized stream ID, and then is valid message with like the command. I'm passing maybe monads here. So I'm instead of so this was because I thought it would be easier to work with maybe. So if it exists or not, then sort of sounds like a maybe monad for me. So if there is a user in the request or there is not user in the request. And then when this is valid is executed, I pass on the next, which is on the and then line in the middle. So if the valid is success, then it goes to the and then part. Where I do the find message, I go to the repository, and whatever I get from the repository, I pass to the next function, which is post message, which takes a command, and that sort of returns a function that takes whatever the find message returns. So I bind these chain these functions together, and then whatever post message returns is being passed on to the save entity repository stream ID, and there is the third argument that is not visible here. So I chain these functions one after each other. And the stream ID here at the end, just above the bimap, is the input or the first argument for the find message repository function that I have in the and then list of chainable methods. Yeah, in the end, just mapping things so to get something valuable there. And as you can see, I'm still having strings there. I'd rather have types or something that is easier not to create errors with. So thinking from this hexagonal perspective, it is like instead of errors thrown, like what I used to do, instead of errors thrown and then catching up and catching things and doing all the logic in my roots, my domain is always returning a result. So that is sort of like the protocol I'm defining in my domain. So domain returns a result of T. Result basically is either a failure or a success of T. So the change is something somewhat like this. So the one above, the old way, I don't have code like that. I just wrote it down just to make it look like this is roughly the way I would have done it. And the one below is actual work and actual code. Well, eventually things happen. Meaning some of these actions, or some of the functions are things that happen eventually. Like in Haskell, the I/O functions just happen eventually. Getting stuff from a database is not that it's now there. It just happens eventually, sometime. So how is this thing called eventually or future handled differently in the code what I'm showing to you? Because things eventually happen. It's not. whatever eventually happens basically returns either success or a failure. Then it's just how I'm using it that how I'm like in the routes, how I'm handling the thing. I'm just waiting. There's like fork method that waits until the result comes. So why do I have two things here? The ones above are things that I can like calculate immediately, that return instantly, that are not asynchronous. And the ones in the and then part are things that happen eventually. I think if I'd want, I could make everything to work with futures, everything to work the same, so I would just have like 6 methods together. It's just, I'm not there yet. I might actually do that and just to see how this looks like. So I've never ever, by the way, used so much time for this small amount of code that I'm showing to you. So there's like tens of hours, probably hundreds of hours, because I wanted to understand FP. I wanted to understand what it is to work this way. And you know, I've like banged my head on the wall so many times, and I've put numerous hours in this. And by the way, if you think this is not good or you want to give me feedback, please do. Honestly, I'm still learning, and this is just my code. It's not me there. So even though if you think it's like total crap, it's not. I don't take it personally anyway. So this is what it looks like now. So the code that in Node.js. So I can say something that happens now, something that happens in the future eventually, and then the rest happens anyway. So the biomap is something that is anyway it's called, so where I can return whatever I want to the routes. Talking about the routes, where I used to have the error catching and whatever happens in there. I actually started from routes because I wanted to. I have another slide set where I can show like the pathway, like not all the commits, but a lot of commits where I came up into this way of working with these things. So this is what the routes look like now. So I sort of describe what happens on errors. I sort of describe what happens when it succeeds. And then I just get, okay, just give me the result eventually. And then I say handle this feature, which basically it's just a wrapper for forking, which then eventually calls the on error or calls the on success. And that's sort of it. So there's not much code. There's not much things to sort of show. This is the thing what I did. So I did. What I learned, I think there's quite interesting things. What I learned is that I can compose the domain logic, and with domain logic I mean also authentication and authorization, which might be really crucial from the domain logic perspective. Validation too. Those are all pure functions in my code. Those are all pure functions. My domain or the domain protocol is that it returns. So the use case or the command handlers, they return either failure or success. One of the cool things is that domain logic and all these functions, because they are pure, they are super easy to test. It's super easy to test. It's easy to test drive my routes. It's easy to test drive my domain logic. It's easy to compose functions out of this. And where are all the side effects? I think Haskell people would enjoy this. So where are all the side effects? The side effects are in the boundaries. The side effects are, there are the impure web where I need to work with return requests and responses, where I need to modify the state of the response. They are where I'm sending emails. they are where I'm reading data from database or updating data into database. So my impure functions are in the boundaries. And the domain logic is, well, I think they are pure. If some would come and see this code, they might, I don't know, they might find some impure there, and then I'd really like to learn how to make it pure. So these are sort of the things that I found out when I started to work this way. I just wanted to learn, and this is how I eventually ended up to. There are a couple of slides here on the testing, which I'm really sorry about the slides. They look really bad here. But this, if you look at the shape of the tests, they often are like three-liners. So, so the one down here, for example, it says that if I put a request user to be undefined, then the redirect to should not have been called, for example. Or it should have been called, because if it's not defined. So testing is surprisingly easy. It's surprisingly easy to test like the roots. It's surprisingly easy to test domain logic and all this stuff. I have a couple more slides on testing, but you probably can't see the text there. So this is sort of my presentation, and I would really love if you want to see more, talk more about this. I have the code with me, so we can go to OpenStage or OpenSpace place, for example, or something else. If someone would like to try this themselves and want to see the code themselves, if people want to open source whatever there is, so if someone wants to help me with that, I'm open for that too. And maybe now if you have some questions or comments you want to share with all the folks. Yes?
Yeah, so for a long time, for years, I've coded the first way you presented, which is not the approach you wanted to show, but the alternative way, which is I have code that runs along maybe one track, and every time you fail something, you throw an exception. And the alternative you're presenting is to always return and just return either a success or an error. What I don't understand is, can you tell us what the advantage and inconvenience are of doing it that way instead of throwing exceptions? That is not yet clear for me.
One of the reasons why I wanted to work this way is to answer exactly that question. I'd say both are valid ways to do it, and the way I've used to do it before, that's as I've done most of my work with that way. It's faster, it's easier, it works, it provides value. So, and this is fun. It takes a lot of effort, and there's a lot of learning. So I would say I wouldn't say this better or this better. These are like some of the benefits I see from both. The other ways, the current way which I'm using, I would probably work that way, like in my current projects, and not this way, because this is so different.
Okay, thanks.
Yes, there's a question.
So you have presented us the TypeScript with every function carried. So we have lots of parentheses. Is it possible the same code to be with a normal function with several arguments, you think?
So is it possible to have the same, to understand correctly, the same structure with less currying?
Yes.
Definitely. definitely, yes. So I just, again, never done anything like this. I just wanted to push everything to the boundaries, like, and even a bit more. So that was one of my ideas. Currying is sometimes it's quite nice that I have like, well, if I wouldn't do it this way, I would need to then, okay, understand what are the things I sort of, like for example, there is some place where I can curry a function, like where I'm putting up my Node.js app, and I already there inject the first parameter of the repository, for example. So it's sort of easy if everything is of one function parameter, so then it's easier to do the currying whenever I sort of have the information that I can then present to the functions. But yes, I could, definitely. Do you have other questions? Well, thank you.